Hello there, this is Randy. Today we're going to learn how to describe the behavior of a polynomial graph if we go really far in the negative x direction or really far in the positive x direction. We call this polynomial end behavior. Let's go. So there are four specific types of polynomial end behavior that we're going to talk about. The first one, in plain English, we could call start low, end high. The second one is start high, end low. And we'll talk specifically about how each of these look on the graph and how to describe these mathematically. The third one is start low and end low. And the fourth and last one is start high and end high. So let's start by looking at the graph for this first type of polynomial end behavior. So when we say the word start, we're talking about where is the graph on the leftmost part. And when we're talking about end, we're talking about where is the graph on the rightmost part. So you can see that this graph starts down here and ends up here. And here's the equation of that graph. Now, before we talk more about the equations and how to interpret the equations, let's talk about the mathematical description of this type of graph. So we can see that it says as x approaches positive infinity, so x in the positive infinity direction is to the right. So as x approaches positive infinity, f of x, or the y values, f of x is the y values, approaches positive infinity. And that makes sense because the positive y direction is up. So as this graph is moving to the right, it's also going up, and we can see that that's exactly what's happening on that part of the graph. It also says that as x approaches negative infinity, or as it's moving to the left, f of x, or the y values, approach negative infinity. You can see that that's exactly what's happening. It's going down and to the left. Keep in mind that based on this description, the graph really goes for infinity in both directions, but we just say start low and high as a way to simplify it. Now you will see many other examples of graphs that start low and end high like this one, but in the middle, there's a lot more going on. Sometimes the graph will go up and down multiple times, and what determines that behavior in the middle is the equation. So what if we only have the equation? How can we determine the end behavior? First of all, let's remember what is the degree of a polynomial. Well, the degree is the highest exponent in the polynomial. It often is the first term. Just like in this case, the highest exponent is 3. So this is a third degree polynomial. Now here's the key. If the degree of our polynomial is odd, so 1, 3, 5, 7, 9, 11, 13, obviously, and the leading coefficient on that first term when the polynomial is in standard form is positive, okay? So this right here, this exponent is odd, and this number right here, this coefficient, is positive, and therefore we know that this graph will start low and end high, or more specifically described, it will do exactly what our mathematical description describes, okay? Now, if the sign of this first term, of this coefficient, is negative, or if the degree of our polynomial is even, then the end behavior will be different, and we'll talk about those scenarios as well. So for start low, end high, just remember that the leading coefficient is positive and the degree of the polynomial is odd, and we know that it will be a start low, end high graph. Now this next type of end behavior is the one that starts high and ends low. It's kind of like the opposite of the first example that we talked about. So in this case, we say that as x approaches positive infinity, as it moves to the right, f of x, or the y values, approach negative infinity, so it goes down, just like we can see on the graph. And as x approaches negative infinity, or as the graph moves to the left, the y values approach positive infinity, or they go up. So we can see that just like it describes, the graph behaves that way. So now, what about the equation? Well, just like our first type of end behavior, if we have an odd degree, then we know that the graph could start high and end low. But the other factor that we need to take into account is the sign of the leading coefficient. In this case, we have a negative leading coefficient. So if our equation has an odd degree and a negative leading coefficient, then we know that the end behavior will be like this example. It will be a start high and end low graph. And we're assuming that each of these equations are actually f of x. F of x is equal to all of that, but just for simplicity, we didn't write f of x every time. In other words, in each example, the expression right here is f of x. Now, if our expression is in standard form, that is when the exponents are going in descending order, we only need to pay attention to the first term, and we can ignore the others when we're trying to determine the end behavior. So another way to think about it is all we need to pay attention to when we're trying to determine the end behavior of an equation is our degree even or odd, and what is the sign of our leading coefficient. So if we had, instead of 3 right here, if we had 5 or 7 or 9, then this would still have the same end behavior. Just like if we had, instead of -2, -5 or -20, it would still have the same end behavior because the sign is still negative. All right, let's look at 2 more types of end behavior. This next one is what we call start low and end low. And here is the mathematical description of this type of end behavior. I'll let you read that if you want. Just like in the first 2 examples, this mathematical description is just describing what happens on the graph in the extremes to the left and to the right. So how do we know if an equation will start low and end low, such as in this case? Well, once again, we just need to pay attention to the degree of the polynomial and the sign of the leading coefficient. So 4 is the degree, and the sign of the leading coefficient is negative. So because our degree is even, just like if it were 6 or 8, and because our leading coefficient is negative, just like if it were -4 or -10 or -50, because it's negative and even in these 2 different characteristics, we know that the graph will start low and end low. So our last type of end behavior, in plain English, we could say start high and end high. And here is our mathematical description, which is also expressed on the graph. And now looking at our equation, if we have a degree that is even, such as in this case, 4 is even, and a leading coefficient that is positive, then we know that our end behavior will start high and end high. So much like in the previous example, if we had something like 2 or 6 or 8, any even number as the degree, and our sign of the leading coefficient were positive, then we know that this same end behavior would apply. So it will probably feel a little bit strange at first to be using this mathematical terminology because it's kind of hard to conceptualize at first, but as you practice, it will start to feel more normal, more comfortable. So I encourage you to pause the video and try to describe the end behavior of each of these functions in mathematical terms. In other words, try to figure out which of the 4 types of end behaviors that we talked about correspond to each of these 4 expressions. And because of the rules we discussed regarding the degree of the polynomial and the sign of the leading coefficient, you can see that right here I drew an arrow from each of those 4 functions to their corresponding end behaviors. And with that, we are finished. See you next time.